Hi everybody, my name is Ažbe. I'm reporting from Slovenia, from the lab at Sartorius Bioseparations cutting-edge facility. Sartorius Bioseparations is the global leader in monolithic chromatography. Chromatography is the gold standard for purifying safe and pure AAV therapeutics at large scale, reducing cost per dose and also time to market. And let me show you how you can facilitate your AAV downstream process by using simultaneous monolithic columns. This is 1 milliliter column, the smallest column within the simultaneous lineup. And we offer a wide range of chemistries, but as you can see, we offer also a wide range of sizes. So from 1 milliliter size up to 40 liter column. And we offer this in two different housings. So this is epoxy thermoset housing, and this one is stainless steel housing. But not only that, if you wish to use the same monolith for screening or analytical purposes, we have such products as well. So SIM multi-well plates, so 96 well or 24 well plates, and also SIMAC analytical column. So back to the preparative chromatography. This is an example of cross-section of 800 milliliter stainless steel column. And the most important part you can see is this. So this is the monolith. And when the sample is applied to the column, it enters here. Then it's distributed to the outer side of the monolith. It goes through the monolith in a radial way, and it goes out here. So radial flow allows very high flow rates at any chromatography scale. And if we zoom in the monolith, we will see only channels, no dead-end pores. And these channels are highly interconnected. And due to high interconnectivity and also due to convective mass transport, there is actually no diffusion and almost no turbulent forces, resulting in flow-independent high-resolution separation and also flow-independent capacity, while maintaining very high recoveries. So at Sartorius Bioseparations, we develop purification process that is based on monolithic columns. And this is all to eliminate process-related impurities as well as product-related impurities. But in the first chromatography step, we are actually focused on removing process-related impurities. So like whole cell DNA and whole cell proteins. A cost-effective and versatile chromatography column for this step is simultaneous SO3. So simultaneous SO3 is actually a platform product for this step because it allows to bind and also to elute any AAV serotype and also any engineered capsids. And besides, it's also a multi-use column, so cleanable with molar sodium hydroxide, thus decreasing the cost per process. And now, let's turn it over to Blaž, who is joining us from the Analytical Development Lab.
I'm joining you from our Analytics Development Lab, where we've just unveiled a new solution for AAV vector analytics. As we know, for AAV therapies, optimized production and purification process is a big part of the final product success. Both high purity and high process yields are important, while further constraints are imposed by ensuring that the process is also scalable and the ease at which we can implement it in a GMP environment. Success often hinges on deep evaluation of critical consumables, such as filters and columns, for which robust process parameters need to be found. With so many variables on the path to success, A tight integration between purification and analytics during process development is crucial. Rapid feedback on full capsid recoveries and impurity removals during optimization of downstream steps leads to better product outcomes down the line. CIMAC analytical columns harness the core advantage of monolith technology while also additionally being optimized for the best resolution between very similar and very large analytes like empty and full AAV capsids. With our novel approach to analytical chromatography, we are able to baseline separate different AAV subpopulations and simultaneously analyze them with multiple detectors, such as the Miles detector, the fluorescence detector, and the multi-wavelength UV detector. Together with the standard curve, AAV concentrations of different subpopulations can be determined. This allows calculations of process recoveries and monitoring of successful removal of undesirable AAV subpopulations like the empty capsids. But process samples contain much more than just AAV capsids. Especially bothersome are the host cell debris like soluble proteins and nucleic acid impurities that make analyzing pre-capture samples much more difficult. This is why orthogonal multi-detector analysis of process samples is key, overcoming this challenge that is posed by interfering impurities. Bringing all of these aspects together is the PATfix AAV platform, where we are providing a complete solution that doesn't include just the hardware, but also the methods, buffers, columns, and standards that are required to successfully operate and receive analytical results for AAV samples. Because we've already done extensive method development on the same hardware, it makes implementation of the PATfix analytics much easier in a fast-paced process development environment. Combined, these features create a complete solution for PD labs looking to expand their analytical capabilities and speed up the important work of purifying the full AAV capsids from the complex upstream material.
We have applied these insights to the polishing step as well. AAV empty-full separation is known as one of the most challenging separation in gene therapy industry.
But it doesn't need to stay this way.
Indeed, Blaž. With Simultaneous QA-HR, it's possible to obtain reproducible empty-full separation across the entire scale. Selection criteria for QA-HR are very strict, based on the real AAV empty-full separation and very narrow selection criteria. So, implementing step gradient is now easier than ever with this monolith.
Combining this QA-HR monolith technology with our novel empty-full methods, what we can achieve is baseline empty-full separation between the AAV capsids. This allows us not only to more robustly implement step gradients, but also allows us to implement advanced chromatographic techniques such as flow-through mode, where we can basically preferentially enrich full AAV capsids while letting the empty capsids be in the flow-through, not even bind to the monolith.
So, combination of both, simultaneous SO3 for AAV capture and simultaneous QA-HR for enrichment of full AAV capsid allows rapid process development, seamless scale-up, high process yields, and also consistent quality of AAV therapeutic drug.
But what if our clients lack the time, the personnel, the equipment, or general monolith knowledge to implement such techniques for themselves?
Not only those, Blaž, there are many possible reasons why developing purification process can be challenging. This is why our process development cornerstone team is ready to assist with development of a purification process tailored to customer-specific AAV sample.
And what's the outcome of such cornerstone services?
So once the client is satisfied with the process, we will provide comprehensive SOPs and seamless tech transfer equipped by on-site support of our cornerstone process development experts. So, if interested in such service, please reach out to our Sartorius colleagues.
And with that, back to the studio.